Good morning, everyone. Welcome to the first lecture of Atomic Structure and Chemical Bonding, Class 9. Myself, Suman Singh. So, today we are going to learn about the atomic structure. So, before starting atomic structure, we will know some of the things which is related to this chapter, that is atom. So, what is atom? The concept of this atom, or we can say that atom is what? It is the smallest particles of any matter. Okay, it is the smallest particle of any matter. Suppose we are taking any matter. Suppose we are taking here sugar ball, or we are taking here suppose this is a sugar ball here, and what we are doing, we are just dividing this sugar ball into a smaller and smaller pieces. Okay, so a time will come when this sugar ball will become so small that it will not be able to see with our naked eyes. At that time, what we can say that this particle is atom. Okay, so this about this atom, we previously, when we are not knowing anything about this atom, some of the scientists, or we can say that Indian and Greek philosophers, has given some ideas about this atom. Okay, so what they have told in India, when we talk about the idea of the matter, was in India, once scientist, or we can say that the philosopher name is Maharishi Kannad. Okay, as you can see here, it is written Maharishi Kannad, right? So what he has told, what he has given the idea about the atom, he says that if we go on dividing matter, which is in Hindi we call matter as padarth. As you can see here, it is written padarth. So what Maharishi Kannad has told, that if we will go on dividing this matter into a smaller and smaller pieces, okay, so ultimately a time will come when this particle will become so small that we will not be able to further divide that particle. Okay, and that particle he has given the name what? Pramanu. Okay, so what Maharishi Kannad has said, he told that if we are taking any matter or any padarth, and if we are going on dividing that matter into a smaller and smaller pieces, so a time will come when the particles will become so small that we cannot further divide that particles. Okay, so that particle he has given the name what? Parmanu. Okay, he has given the name what? Parmanu. Okay, he has given the name Parmanu. So and another scientist, or we can say that Indian philosopher, you can see here the name is given here, Pakuda and Katyan Katyama. Okay, so what they have said about this matter, they says that, or we can say that what they have given the idea about this matter, they said that the particles normally exist in these particles normally exist in the in combined state. Okay, which give us various form of matter. So just I will give you one example, then you will understand clearly. So these two philosophers, what they have said, that whatever the Parmanu, which Maharishi has said about the Pramanu, that Pramanu exists in a combined state. Okay, they used to exist in a combined state, and they used to form a various form of matter. Just like the example, if we are taking, suppose we are taking an atom of hydrogen, and we are taking an atom of oxygen. Okay, so these two are combining together, and it will form what? Water, right? You know this. After that, if we are taking this carbon, and if we are reacting this, and if we are taking the atom of oxygen, then it will form what? CO2, right? Or again, if we are taking carbon, and if we are reacting with oxygen, then in some condition it will form carbon monoxide. So in this way, if we are asked to find out the atom of carbon, so it will be in the combined state in the form of H2O, or if we are talking about the carbon, it will be in the form of CO2 or CO, like this. or more, so many examples are there. If you want to take other example, we can take another examples also. If we are taking here NaCl, so how this NaCl is formed? It is composed of sodium plus and calcium minus. So this is an atom of sodium and chlorine, sodium and chlorine, sorry, sodium and chlorine combined together to form what? NaCl, right? Sodium chloride. So what this Pakuda and Katyanam, uh, what they have said, that whatever these particles which Maharishi Kannad has said about Parmanu, this Parmanu exist in a combined form, okay, and when they are in a combined form, they form a various form of matter. So this was about the what Indian philosophers have said about the atom. Okay, so now we will see in the same era, Greek philosophers also were what we can say. These Greek philosophers were also doing some work on the matter, and they were also trying to figure out what this how this matter is made up of, right? So in the same era, this Greek philosopher, one you can say that name is given Democritus and Lycurgus. Okay, they too also suggested that if we will go on dividing this matter, okay, a stage will come when the particle will become so small that we cannot further divide that particle, or we can say that that particle will become indivisible. Okay, so that what they have given that particle, this since Maharishi Kannad has given the name Pramanu, right? Prmanu, right? Maharishi Kannad has given this name, but the Democritus and Lycurgus, they have given the name as atom. I hope you are understanding this. So the concept was same. In the same, whatever the Maharishi Kannad has said, this Democritus and Lycurgus, both of them has said the same thing, that the if we will go on dividing particles or a matter, any matter, into smaller and smaller pieces, a stage will come when the particle will become so small that we cannot further divide that particles, and that particle he called that atom. Okay, so this word atom has been derived from the Greek word, right? From the Greek word atomus. Okay, you can see here from the Greek word atomus. Okay, atomus. And what is the meaning of this atomus? Its meaning is indivisible. Indivisible. Okay, indivisible. So this word atom has been derived from a Greek word atomus. As you can see here, it is written. The word atom has been derived from the Greek word atomus, meaning indivisible. Okay. Now, so this was the concept of Democritus and Lycurgus. Okay. Now, in 1808, one scientist named John Dalton, okay, he was a famous scientist, and he has given his atomic theory, okay, and this his theory was considered as a fundamental building block of matter. Okay, whatever the theory he has given, that theory has what we can say, that theory was very much considerable, or we can say that whatever the theory he has given at that time, most of the people or most of the scientists has accepted that theory. So what was the theory, or we can say that what was the main postulates of this Dalton atomic theory? So the main postulate is whatever this Democritus and Lycurgus, Maharishi Kannad has said about the atom. This Dalton has also said the same thing. What he has said, he says that all matter, whatever the matter it is present, any matter. If we are talking about any matter, all matters are made up of very tiny particles called atom. Okay, as you can see here, it is written, all matters are made up of very tiny particle called atom. Now, again, what he says that atoms are indivisible particles. Okay, what he says, atoms cannot be further divided, okay, which can neither be created nor be destroyed in a chemical reaction. Means what he means to say that if we this atom, if this atom we are dividing this atom, or if we are trying to divide this atom, or if we are trying to break this atom, so it is indivisible, means it will not be further, it will not be divided, okay. And if this atom is doing any chemical reaction, so it will retain its property, okay. I hope you are understanding this. What he was trying to say that atoms are indivisible particle which can neither be created nor be destroyed in a chemical reaction. I will give you one example, from that you can easily understand. So suppose we can say that this is a atom of carbon, right? Suppose this is an atom of carbon. Wait, this is the atom of carbon, okay. And suppose this atom of carbon is reacting with this oxygen, okay. So what it will form, it will form carbon dioxide, right? CO2. So you can see this carbon in a chemical reaction, the atom of carbon is same, you can see here these atoms are same. You can see oxygen atom is also same here, right? But the properties of this carbon dioxide will not be equal to this, okay. The property will be different, but the atoms will be same. You can say, as you can see here, atoms will be same, but the properties are not same, okay. So what he was trying to explain, that what Dalton was trying to explain, that this atom will not be divided. It is not like that if we are reacting this carbon with oxygen, then it will form H2O. It will not form like this, okay. Or it will, if we are reacting this carbon with oxygen, it will not form NaCl, okay. It will remain same, but the compound which they will form, he has given the name compound, the compound which will form, it will be different. Its property will be different from carbon and oxygen, okay. So I hope you have understood this property. What he has said, atoms are indivisible particle which can neither be created destroyed nor be destroyed in a chemical reaction, okay. So I hope this one you have understood. Now next is what he has said, atoms of given element are identical in mass and chemical property. What he says, atoms of identical elements are atoms of given elements are identical in mass and chemical property. So what he means to say, I will show you one example. Suppose we are given here hydrogen, sodium, or potassium, or chlorine, like this. We have given the atoms of hydrogen, atoms of sodium, atoms of potassium, and uh, atoms of chlorine. After that, again we have taken here again hydrogen, sodium, potassium, and chlorine, right? So what he says, that the atom of the given element, suppose the atom of this hydrogen and this hydrogen will be entirely same in what, mass and chemical property. In the same way, atoms of this sodium and this sodium will be same in mass and chemical property. In the same way, this sodium and this potassium will have the same mass and chemical property, and this chlorine will have same mass and chemical property in respective of their sources. From any sources, if you will bring this hydrogen from any other sources, and this hydrogen if we are bringing from other sources, and if this hydrogen you are bringing from any other sources, then it will not depend on the sources. It is not like that if we are bringing if we brought one hydrogen from somewhere some other place, and one hydrogen this hydrogen from other place, so it will be different. No, it will not be different. It will be same irrespective of the sources from where it has been brought, okay. In the same way, this sodium and this sodium will be same in chemical mass and chemical property. This potassium and this potassium will be same in mass and chemical property. In the same way, this chlorine and this chlorine will be same in mass and chemical property, okay. So this was his theory. What he says, atom of given element are identical in mass and chemical properties, okay. Now next, Next, what he says, atoms of different element have different mass and chemical property. Okay, what does it mean? It means that if we will compare the mass and chemical property of this hydrogen with this sodium, it will be different. Okay, if we are comparing the mass and chemical property of this hydrogen and this sodium, it will be different. This hydrogen and this potassium, it will be different. If this hydrogen and this chlorine, it will be different. If we are comparing this sodium and this hydrogen, it will be different. If we are considering this taking this sodium and this potassium, its mass and chemical property will be different. In the same way, if we are taking this potassium and sodium, its mass and chemical property will be different. In this potassium and this chlorine, its mass and chemical property will be different. In the same way, this chlorine and this potassium mass and chemical property will be different. This sodium and this chlorine mass and chemical property will be different. This hydrogen and this chlorine mass and chemical property will be different. I hope you have understood what I mean to say, right? But he says atoms of different element have different masses and chemical property. So now I hope you have understood this. Now next we will move to next what he says, that atoms combine in a ratio of simple whole number to form compound. What I have told you previously, suppose we have taken the atom of sodium and we have taken the atom of chlorine. Okay, so when they will combine in a simple whole number ratio, and they will form what compound. Okay, NaCl. Okay, they will form a compound in a simple whole number ratio. They will combine together to form a compound. In the same way, you can take carbon plus oxygen, it will be CO2, right? So this carbon and this oxygen will combine in a simple whole number ratio to form a compound, and the compound which they will form, its property, chemical property, if you are talking about the chemical properties, physical property, mass, atomic mass, everything will be entirely different from this carbon and this oxygen. Okay, so if you are talking about this sodium chloride, this its property will be entirely different from this chlorine and this sodium, right? So what he says, atoms combine in a ratio of simple whole number to form a compound. Now next what he says, the relative number and the kind of atoms are constant in a given compound. So what does it means? The relative number and the kinds of atom are constant in a given compound. The same example we will take. Okay, so we will take one simple example. Suppose this is H2O, water, right? And this is also an H2O, and this is also a water, and this is also in water. Okay, these are the four. Both are water. All four are water. But this water we have taken from normal tap water. Suppose whatever it is coming in our house, right? In our home, the tap water, which is this. Suppose this water we have taken from river. Okay, and this water we have taken from, suppose, rain. Okay, rain. Or this water we have taken from, suppose, we have taken this from, you can say anything, sea or ocean. Okay, anything. Okay, so what he tries to say, what Dalton was trying to say is that the relative number and the kind of atoms are constant in a given compound. You can see there is any difference in the formula, or you can say that in the atoms of the water. You can say either if we are taking this water from the tap, its formula will be H2O. If we are taking from the river, it will be again H2O. If we are taking from the rain, it will be H2O. If we are taking from the sea, it will be H2O. Means what he says, that the atoms will be constant. Okay, in a given compound, the number of atoms or the kinds of atoms will be constant. Okay, again we can take some more example. If you are taking the example of this CO2. So if this CO2 is, if this CO2 which we are inhaling from here, if we are taking, if we are taking this CO2 from what we have inhaled, and if this CO2 is where is the what is coming out from the vehicles, or then when we will see the is there any changes in this? No, you can not you can see that there is there is not having any change, right? This CO2 and this CO2 both are same in respective of the sources. Means what they used to what he was trying to explain, that the kinds of atom are constant in a given compound. Okay, if this compound is CO2, its atoms will be, if the compound is a carbon dioxide, its atoms will be carbon and oxygen only, right? So this was the main postulates of Dalton atomic theory. But whatever the postulates this Dalton has given, this postulates was, all the postulates was not correct. Okay, whatever the postulates he has given, or whatever and the whatever he has said about these atoms, or whatever he has taught in his Dalton atomic theory, that theory was not 100% correct. Okay, so although this theory explains so much conveniently, we can say that although this theory conveniently explain the various laws of chemical combination, but this in the modern concept, when we are comparing this model with the modern concept of atomic structure of atom, this theory has failed in so many respect. Okay, means what, this theory was not 100% correct. So, what was the drawback, or we can say that what was the error in this theory? We will see one by one. So, first is what, modification, or we can say that what Dalton has said and what actually we have got is different. Okay, so what Dalton has said, that atoms cannot be divided, right? But as we know that the atom is no longer considered to be a smallest indivisible particles. We have got what, in atoms, inside the atom we have got what, electron, proton, and neutron, right? So here the Dalton atomic theory has failed in this respect also. Now next, where it has failed, what he says, that atoms of same element have same chemical property and mass, right? So that theory also failed, because we have found that after some years we found that there is some of the atoms, or we can say that there are some of the element in which they have the same chemical, we can say that they have the same chemical property and the same atomic number, but their masses are different. Okay, their masses are different. As you can see here, it is also written here, such atoms of same element, such atoms of same element with different masses has been found. Okay, later. So this the and the elements which has same, we can say that same atomic number, same atomic number, but different mass number, but different mass number, such type of element is called, such type of compound, or we can say that such a type of element is called isotopes. Okay, not compound, element is called isotopes. Okay, so isotopes is what, atoms of same element, we can say like this, atoms of same element or different element, we can means atom of same element having same atomic number but different mass number. Okay, means what, sorry, isotopes is what, atoms of same element having same atomic number but different mass number. So here the theory, what Dalton has given, that the atoms of a given element are identical in mass, that theory has failed. Okay, again, next what he says, that you can, I will give you one example. Example is that chlorine. So chlorine comes in two forms. One is chlorine 35 Cl, we can write here. Chlorine comes in two form. One is Cl chlorine, whose atomic mass is 35.5 like this, and another one chlorine used to come, that his mass is 37, right? So you can see that chlorine, both are chlorine, but their mass numbers are different, right? So in this way we can find out that the atom of same element having same atomic mass, different atomic mass but same atomic number is called isotope. So this here the theory what Dalton has given about the mass and chemical property has failed here. Okay, so now next what he says, atoms of different element atoms of different element have different masses and chemical property, right? He says that if the atoms are different, if you are taking different atom, then their masses will be different, but it is not like this. We have after sometimes we found that there are some of the elements whose atomic masses are same, but that element are different. Just like you can take the example of potassium and calcium. Potassium and calcium, these two elements are different, okay, and its atomic number is also different, but the mass number is found to be same as approximately 40. Both of them are having a same mass number 40, okay. Its atomic number is 19, its atomic number is 19, potassium, and its atomic number is 20, okay. You can say both are different element, but their mass numbers are approximately same. So here also the concept which Dalton has given about the atoms combine in the atoms of different element have different masses and chemical property has failed here, okay. Now next is what. So one more thing here, they have mentioned isobar, right? What is this isobar? This isobar is means what? Such atoms or the element which has a different um, atomic number but same mass number, okay. That type of compound or that type of element is called isobars. That type of elements are called isobars. Means what? They will have in the isotopes what was there? Same atomic number, different mass number, but in isobar it will be reversed. Same mass number, same mass number, and different atomic number, okay. Different atomic number, okay. That is called isobar. Now next was what he says, substance made up of same kind of atom may have a different properties, okay. Just like this, what they have said, atoms, the relative number and the kind of atoms are constant in a given compound. Now one more thing, what he says that um, if to any substance is there and that substance is made up of same kind of atom, okay, so their property will be same. What Dalton has says that if any compound is there and that compound is made up of same kind of atom, then their property will be same. But it was found that it is not like that. Many compound we have found that so many compounds are there, their formulas are same, but their compounds are different, okay. We can say that the properties of that compounds are different. You can take one example, just like coal, charcoal, graphite, and diamonds. All are what? They all are made up of carbon, okay. They all made up of carbon, but their properties are different, okay. But the Dalton has says that the if the atom is made up of same kind of if the compound is made up of same kind of atom, then their property will be same. But it is not like that. Here also he has failed. That we have found later on, we have found out that if any compound is there, and if that compound is formed from the same kind of atoms, then same kind of atom, but their property will be different. Just like in the case of charcoal, graphite, diamond, like this, okay. That are called allotropes, okay. Allotropes made up of same atoms, but their properties are different, okay. So that are called allotropics, and these are called allotropic form of carbon, okay. This you will learn in detail about this in class 10 in organic in concept, some basic concept of organic chemistry. There you will learn about this in detail, okay. So now next, what he says next what he says that atom combine in a ratio of simple whole number to form compound, right? Dalton has says that atoms combine in a simple ratio of simple whole number to form a compound, but it's not like this. We have found out later on, we found out that there are so many compounds which has been made up of means we can say that made up of integral or fixed we can say that made up of s- whole number ratio. There is an whole number ratio, or we can say that we can I will give you one example, from that you can easily understand. So what he says that atoms combine in a ratio of simple whole number to form compound, right? But it is not like that. The ratio in which the different atom combine to form compound may be fixed or integral but not simple. You can take the example of like this. If you are taking the example of sugarcane C12, as you can see that in your book example is given O11, right? So when we talk about the composition, we can say that it is 12 is to 22 is to 11, right? So you can say that it is not simple. Okay, it is which is integral and fixed but not simple. He has told that it will be fixed or it will be a simple integral multiple fixed and simple, right? But integral and fixed, we have found integral and fixed, but it is not simple. Okay, so here also the Dalton theory has failed. So this was all about Dalton atomic theory. I hope you have understood this. So in the next class we will discuss about the cathode ray experiment. Till that, thank you.